Hi there. In part 5.7 we're going to be talking about using mole calculations in chemical equations. So in a balanced chemical equation we've been talking about that it tells us how many atoms or molecules that we have. It can also tell us how many moles of each reactant is going to form how many moles of product. And we use that by looking at the molar ratio, that is 1 mole of nitrogen, 1 mole of oxygen is going to produce 2 moles of nitrous oxide, and these are all gases. So this 1 mole or 1 molecule of each one of these is going to form 2 moles or molecules of NO. So the coefficients are used to form the mole ratios. And those mole ratios, as we know, can be used as a conversion factor. And so since it's a 1-to-1 for oxygen, it's a 1 mole nitrogen to 1 mole of oxygen. The ratio between nitrogen and NO is 1-to-2. And then the ratio of O2 to NO is 1-to-2. So we can use any of these as long as we have a properly balanced chemical equation. And so since we can use this in this manner, it's important because a lot of times in a problem I'm wanting to know I need this much of B. How much A is it going to take in order for me to get to that amount of B? So let's look at a sample problem. Using the balanced chemical equation, how many moles of CO are produced from 3.5 moles of C2H6, and that's ethane. Alright, so first of all, I looked at this problem a little earlier and I discovered that this is not properly balanced because I have 4 carbons over here and this would only be 2 carbons, so this should actually be 4 in order for that to be properly balanced. Everything else I think is correct. Okay, so when I look at this, I'm given 3.5 moles of C2H6, so I'm given 3.5 moles of that. The way this is written, 2 moles is going to give me 4 moles of CO, but I'm only given 3.5 moles. So I'm going to use the ratio between C2H6 and CO in order to figure out how many moles of CO I can produce. So I'm going to, now let me correct this before we get too far. Okay, so the conversion factors would be for every 2 moles of C2H6 I can make 4 moles of CO. So 2 moles of C2H6 over 4 moles of CO. And of course, like all conversion factors, I can write it right side up or upside down. It just depends on what I need to get rid of. So when I set this up, I've got 3.5 moles of C2H6 to start with, so I know immediately that I need moles of C2H6 on the bottom because those have to what? Cancel out. So the proper conversion factor is going to be the 4 moles of CO over 2 moles of C2H6. The moles of C2H6 cancel and are going to just leave me with moles of CO, and that's what I want in my answer. So 3.5 times 4 is 14, and then divided by 2 gives me 7. So 7 moles of CO is what I can make if I have 3.5 moles of C2H6.